perhaps as recently as 3 million years ago. A planet's magnetic field is an outcome of its internal activity. Since Mars doesn't have a global magnetic field, it solidified the argument that Mars's interior is no longer active. In short, for years, there was no evidence to indicate that Mars could still be volcanically active. But 2018 marked the beginning of a new chapter in our exploration of Mars. NASA launched the InSight mission, specifically designed to study the deep interior of the red planet. The lander consisted of some highly sensitive seismic experiments, and the initial dataset sent by the lander gave us the first direct evidence of Mars quakes. Although the first tremor wasn't strong enough, over 235 Martian days or sols, the instrument on board recorded 174 Mars quakes. Fast forward to 2022, the InSight lander has detected over 1,300 quakes on Mars. The type of tremors occurring on a celestial body can reveal much about its interior makeup and activity. So, to understand better what is happening precisely inside Mars's belly, researchers conducted a close study of a cluster of 20 recently detected quakes. The data suggested that most of the faults distributed across the planet are not seismically active. But along with that, the researchers also caught hold of something fascinating. The cluster of quakes seemed to have originated in a region called Cerberus Fossae. It is a fissured area of the planet named after a creature from Greek mythology, known as the Hellhound of Hades, which guards the underworld. Now, this is where things turn interesting. This region consists of some features called graben. Here, the tectonic activity forces the faults to open up. Due to this opening, the blocks of crust slip down between the parallel ridges of the faults. The deeper seismic waves had a low frequency, while high-frequency quakes were recorded along the sides of the Cerberus Fossae graben. So based on the seismic data gathered by InSight, the team concluded that the low frequency of the deeper seismic waves indicates the presence of a warm source region, some 30 to 50 kilometers below the Martian surface. This warm region is consistent with molten magma that hasn't cooled down, which hints at a recent or present-day seismic activity. Following this, the researchers inferred that the terrain in this region is sinking under its weight, forming parallel rifts that pull the Martian crust apart. The information drawn from Cerberus Fossae quakes is crucial because they represent at least half the seismic activity present on Mars. Further, when the InSight data was matched with the orbital images of Cerberus Fossae, the quakes were noticed to have occurred very close to a structure in the Cerberus Fossae mantling unit, previously designated a young volcanic fissure. Around this feature, researchers spotted deposits of darker dust. This dust was possibly scattered out in multiple directions from the fissure.